Okay, so next we're going to integrate with functions that might involve some natural log, they might involve some e, but it might not always be obvious. Okay, so as a review, remember when you took the derivative of natural log, you got 1 over u times the derivative of the inside, okay? So all of these rules are going to also incorporate u substitution. So anytime it's more than just x and it's a quantity, you will technically need to do a u substitution. Now, because the natural log has an inherent domain restriction, you should get in the habit, since we don't know anything about the original function yet or the values, to put an absolute value bar around that u quantity, okay? If you forget, it's not a super big deal, but that's why you're going to see it and be like, oh, wait, I don't remember doing a bunch with absolute value. But remember, we're going backwards. And until we know some of those original values, we need to account for both situations, okay? So also the plus c, since we're doing indefinite integrals, and that also works. All right, so we can, we've done regular functions, polynomials, and trig, and so all of those are going to start being incorporated with each new integral rule that we practice. All right, so let's look at number 1. So we have 2 terms in the denominator, and we're not allowed to split those up, so we're thinking, ooh, well, it's not a power rule, it must be a u substitution of some type. So you might have to play around with these until you get more comfortable. So what I'm going to suggest is, what if we let u be the entire denominator? Okay, so then du is equal to -6 dx, and I'm going to divide by that -6. Okay, so now we'll go ahead and match it up. So I see a dx, and that's -1/6 du. This is u, and so I can pull that 4 out with multiplication. And I get 1 over u du. And I know I can reduce 4/6, but I'm not going to yet. And so now it is in that form 1 over u du, so we can integrate. So we get -2/3 the natural log of u plus c. And I know some of you might skip straight to plugging the u back in, and that's fine. I just don't. So -2/3 the natural log of 3 minus 6x plus c, okay? So if you know, like if this would have been something like plus x squared, we don't need those absolute value bars, but because we're dealing with subtraction and x to the first, we want to make sure all those values are positive or negative if needed. All right, number 2. This is probably my favorite question. I always have done this with students in class, and then I almost always ask it on a quiz or a unit exam, and it's one of my most missed questions. I don't even change the numbers typically, okay? And I tell students this too, so they know I'm going to test them. So I haven't decided if I'm going to do it this year or not, but it's always just kind of interesting, like, and it's not like they weren't paying attention, I'll be honest. There's a lot to remember, and I say this about everything, so who can remember everything? Nobody can, not even myself. So if we want to integrate tangent, the first thing we have to think is, well, what derivative was tangent? And you go through all 6 derivatives, and you're like, no, wait, there isn't one, okay? And so that's why this one, it looks so simple and innocent, but it's actually trickier than it looks. So what we need to do is we need to go back and rewrite tangent as sine over cosine. And so not even making this tricky, because sometimes I'll put a number in front. That makes it a little harder, but this is the basic concept. So if we write it as 2 different functions, then we want to try a u substitution. So sometimes you have 2 choices, but on this problem you actually only have 1. We need u to be our denominator. So du is negative sine, then sine is 1, and then dx. So I don't need the negative. So we'll go ahead and divide by that. All right, so then we're going to match it up. So I see a sine dx, and so remember, those are being multiplied, and so are those. So I get negative du, and then cosine is u. So we get negative 1 over u du. Now I like to write that just to make sure, like, ooh, did I cover everything? So now it's negative the natural log of u plus c. So negative natural log of cosine plus c. Okay. Now, keep in mind, if this was multiple choice, because this is natural log, we do have the option of a power rule. So if you don't see a negative in front, remember that could have been applied as the power. So I'm going to do it over here. We would have natural log of cosine to the -1 plus c. And remember, -1 means it's the reciprocal. And so natural log of secant. Now, would they do this? Who knows? Okay, so this is a good answer. But if that's not one of your multiple choice answers, remember those natural log properties and they might use it. Okay, so be flexible, especially with trig. You just never know. Okay, I can't predict. All right, I took up some of my space, but it's okay. On the next problem, we've got, looks pretty complicated. So I'm going to pick u to be my denominator. And then du, remember, we're going to need a chain rule. So 0, the derivative of sine is cosine, the inside stays the same, and the derivative of the inside. Don't forget that. So I actually don't need that too. Okay. So we'll match it up. That's u. That's 1/2 du. So we get 1/2 1 over u du. So 1/2 natural log 2 plus sine 2x plus c. And because of this addition, if I brought that up as a power, it doesn't make it much easier. So they might change it as a square root. Who knows? All right, so now when you take the integrals of rational expressions, sometimes you might think, just like on those 3 problems, that your u is going to be the denominator. But sometimes it's not. So just kind of play around with things. So I look at the first example, and it looks like, ooh, wait, what do I want? This looks kind of tricky. Okay, so you might try a few things, and if they don't match up, you might be stuck, and so email me, and I can give you a hint. Usually my hint is I tell you what is u. All right, so, and it's a quick email. Don't feel bad. This would be happening in a classroom, and so it's super quick, and that's what I do. I just walk around all hour, and I just give little hints. I don't tell people how to do these problems, because you really do need to figure them out yourselves, but a hint helps. So in this problem, I see something to the 4th, I see an x in the denominator, and I think, ooh, if I have an x, how am I going to get natural log? I don't know how to integrate natural log. And so what happens is usually with the odd thing, I let that be my u. Because we can do a power rule, so I don't worry about that. So du is, remember the derivative of natural log is 1 over the inside times the derivative of the inside. And so you can think of this problem as, there's a 1 there, and you can think of it as 1 over x times the natural log of x to the 4th. These are the same, okay? So if you can't see that, I like to show it at least once so you can mentally start grouping things. So this is u, and then all of this is just du. So we end up with the integral of u to the 4th du. And so this turns into a power rule, which, oops, we can do. So u to the 5th, divide by that, plus c. Notice I've done my integral, so I don't have my symbol anymore. So we get, with natural log, we typically can write that in the middle. I like to. And this would be our integral, okay? All right. This problem might seem super easy now, but in the next section, you'll start to see why this might get more confusing. So we see a radical, I see x squared, and I think, ooh, u is usually the higher power. So I'm going to try that inside. and we can divide by a -2. And so we do have that. So I get the natural log. Sorry, I don't know why I said natural log. This is u. This is -1/2 du. And so we get -1/2. And then we have 1/u to the 1/2 du. Okay, and so this is not a natural log problem. So we get -1/2 u to the -1/2. And then we want to do a power rule. So add 1, so -1/2. So u to the +1/2 multiplied by the reciprocal plus c. So the 2's cancel. I get -16 minus x squared plus c. All right, the last one we've seen before. So just as a review, remember to split these up. So x squared over x minus 2x over x plus 1 over x. I brought it here just to remind you that we can do those separately. So we get x minus 2 plus, we want to leave this. You probably could have done this before, but so this is going to be a power rule. This is going to be a power rule, and this is going to be a natural log. Okay, so now let's talk about e. So this one is my favorite because remember, the derivative of e is e to the u times du. So when we integrate, as long as we've done a u substitution, then it's going to be the same integral. All right? So just remember, u substitutions do need to be applied. So some of these look super crazy, but they're actually pretty nice. So we just start thinking like, ooh, I have e to a trig times a trig. And so typically your u, I call it, it's still a u substitution, is the exponent. Not always, but so derivative sign is cosine. Remember, we're not allowed to divide, but we don't want to. So this is u, and then this is just du. I don't even have any signs to worry about. So we get e to the u du, which is e to the u plus c. So e to the sine plus a constant. All right. Try another one. So this one looks kind of odd, but let's see. If we let u be our exponent, well, remember that's really x to the -1. So du is going to be a power rule, which is really -1 over x squared. And I kind of have that. Remember, I could have like a 1 here, and we can group these together. So I don't need the negative, so I'm going to have negative. This is all negative du. And then this is u. So notice it is in the numerator. So we get the integral is -e to the u plus c. So -e to the u plus c. All right, same idea here, just a little practice. So we get eu equals, what if we make it our entire denominator? So -e to the u times 4 dx. And I don't need the 4 or the negative, so -1/4. Okay. So this is u. And then all of this is -1/4 du. So -1/4, 1 over u du. And so, oops, what did I do? Yeah. So this isn't going to be an e integral. This is natural log. So I get -1/4 natural log of u plus c. Now, if this was just e to the u, remember e to a power is negative, never negative. But with this minus here, we're not so sure. So I would just leave it on. So negative 1/4 natural log. And because of this minus here, if I bring that up, natural log and e next to each other cancel, but that 4 changes everything. So remember, if you had like natural log of e to the x, natural log and e cancel. But this minus changes everything. So if they do simplify some things or your answer doesn't match, use some properties, okay? All right, well, on your practice, I want you to try all 8 problems. I just kind of mixed and matched them and see how you do, okay? Good luck.